So this video is going to go through questions 6 to 10. I think this is probably the hardest set of questions actually. So if you find this set of questions difficult, don't be put off. Make sure you keep going and watch the next two videos because there are a lot easier questions on those two. I think this contains definitely the hardest set. So the first one here is to describe the single transformation that maps A onto B. So make note of the word single, that just means one transformation. So you cannot say things like a reflection, then a rotation, that's two. So transformation is the other key word, and for revision's sake, they are reflection, rotation, enlargement, and then translation. So your first mark is going to come from choosing which one of those transformations it is. So enlargement is clearly not got any bigger. Translation is where it just moves from one place to the other, so like a copy and paste. And so that leaves it down to reflection or rotation. So in the exam, if you can't spot what it is, if you trace over A, if all you have to do is turn your paper to fit onto B, it is a rotation. Whereas if you have to flip over the tracing paper to fit onto B, then that means it is a reflection. So when we did this in class, I can remember that when we traced over A, we had to flip over our paper. So you would get 1 mark for writing reflection. And then this is a 2-mark question. So the other mark is coming from the line of reflection. So you would say reflection in the line. And the reflection line is this one here, where it goes through 0, 0, 1, 1, 2, 2, 3, 3. And the name for that line is y equals x. So it would be reflection in the line, y equals x. Right, part B is a little bit more complicated. So basically A can be mapped onto B doing these two things. So a transformation T that we don't know, followed by a reflection in the line x equals 0. So if we work backwards and reflect B back in the line x equals 0, so the line x equals 0 is a vertical line through 0. So that point's going to go to there, that point will go to there, and that one down there. And so what they're saying is that they would have got from A to this triangle doing transformation T, then they would have reflected it in the line x equals 0 to get to B. And we've got to say what the transformation would be to get from A to this triangle here. So again, it's clearly not enlarged. It hasn't just been copied and pasted, so it's not a translation either. So we boil down to reflection and rotation again. So if you trace over A and just turn your paper, it will fit onto this one. So it would be a rotation for 1 mark. Then you've got to say how many degrees. Well, it's 90 degrees and it's in this direction like that. So that is anti-clockwise. So you can either say 90 degrees anti-clockwise or you could say 270 clockwise. And then you've also got to say what the centre is. So the centre is basically where you trace over A and where you've got to hold it down to fit on to this one. So if you traced over it, held your paper down here, for example, it wouldn't fit onto that triangle where it is. The only place it does work for this particular one is 0, 0. So when you trace over A, hold it down on 0, 0, and turn your paper, it then fits exactly onto this one. So the centre is just 0, 0, or you could call it the origin, that's also 0, 0. So that is question 6. Right, question 7 is a question where you can see it's talking about construction and showing all your construction lines. So that tells you you're going to need a compass for this question. So with this question, there's 2 bullet points, and they do tend to be bullet points in these kind of questions to break it down into steps. And usually one part is easier than the other. So this question here, we know the shopping centre needs to be nearer to the road from A to B than the road from A to C. That sounds pretty complicated, but when you look at the next bit, less than 14 kilometres from C. That's pretty easy to do. Using our scale here, every centimetre represents 2 kilometres. So if it's 14 kilometres, I would need to open my compass out to 7, which I've already pre-done. So I'm going to put it on C, and I'm going to draw a 7 centimetre circle around C, like that. I'm not going to do the whole thing because it goes out of the range anyway, so I don't really need to do this bit down here. But basically I know that it needs to be anywhere inside of that circle. Right, the next bit then, nearer to the road from A to B than the road from A to C. So the road from A to B is this line here. The road from A to C is this line here. So we've got two lines that are meeting at A. So where are you going to put your compass? You're going to put it on A. Now you can open it to any distance that you like. So I'm going to keep it on the 7 that I had before. And I'm going to draw an arc like that. And it should cross the two lines. So mine is crossing here and here. So if I do it in pencil, you can see so there's a point there it crosses and a point there that it crosses. So where are you going to put your compass next? On those points. Obviously not at the same time. So if I do it on this one, don't open up your compass to a different distance, keep it on the same one and draw in your arc. Then do the same on the other one and draw it somewhere in the middle. And then they are crossing over here. So what I need to do now is join that up to here. So I'm just going to pause the video while I do that. Okay, so my line looks like that once I have joined them up. So the point of that line, it's called the angle bisector. The point of it is that it cuts this angle here exactly in half. So if this line is then halfway between AB and AC, I want to be nearer to the road to A to B. So if this line is halfway, it's going to be basically above the line. But remember, it also has to be within 14 kilometers from town C. So it needs to be inside of that circle that I've also drawn. So therefore it would be this section here that I would shade. So part B is a little bit of a weird question. It's not really that mathematical. It's more a geography question, like someone mentioned in class. So explaining why that region may not be an appropriate site. So there's loads of different reasons really. As long as it is something, it's only one mark, as long as it's something that kind of does make sense and it's a valid point. So for example, it might be that although that's the place to suit that criteria, the land there may not be suitable to build on. So it could be like prone to flooding, for example. It may be that the roads going into that area wouldn't cope with the extra traffic that a shopping centre would bring. So anything like that really is just kind of a valid point of why you may not be able to build there. Like I say, it's only one mark, so it's nothing too complicated. Right, question 8. So here we go. This is a nice 5-mark question. So a 5-mark question like this, where it looks, to be honest, I'm trying to do this from your point of view. If you looked at this in the exam, I think a lot of you would probably not know really how to even begin it, because you can see it's going to be to do with circle theorems, but it's hard sometimes to spot the correct theorem to use. And then it's also, you think it's circle theorems and then it's talking about area, so you wonder what on earth is going on. So first thing, I'm just going to approach this from the I haven't got a clue angle. So area of a circle, we're trying to pick up marks where we can. We don't want to drop 5 marks. So area of a circle, everyone in the class knows, is pi times r squared. So looking at that diagram, it's always worth just thinking, can you work out the radius? Well, we know the radius is from here to here. I mean, it's a 5-mark question, so realistically it's not going to be just a case of saying, oh, the radius is 5 and working it out. But if at the end of the day, if you cannot see anything else with the question, make up a radius. So say it's, I don't know, 5, and then do pi times 5 squared. So then at least in the mark scheme it will say pi times their radius squared. So if you've done that, that's going to get you at least 1 mark for doing that. Obviously the wrong answer, but it is the right workings. So then going back to this, you may have spotted that if this angle here is 28, this one up here would also be 28. So if you had labelled that on and still made up your area, that's 2 marks out of 5. The next circle theorem is that you've got a diameter here. So that means the one opposite here is going to be a right angle, 3 marks. Next you're going to be trying to find this distance here. Now, this is now a right angle triangle. So what topics have we done with the right angled triangles? Well, we've done SOHCAHTOA and Pythagoras. So if we're trying to find a side, we only know one of the others, so we can't use Pythagoras, and the fact we've got an angle here suggests it's going to be trigonometry. So this is the longest side, that's the opposite, that's the adjacent. We know that O is 6.4, and we're trying to work out H. So that tells us it's going to be this triangle. I'm going to cover up the H because that's what we're trying to find, and so I've got to do O divided by S. So 6.4 divided by S, which stands for sine 28. So I'm going to work out what that is. So 6.4 divided by sine 28. So that is 13.6323486. Don't round anything yet because we're not at the end. So that's going to give me the whole thing. I just want the radius, so I'm going to half that. So it's already saved on my calculator, so divided by 2. So that equals 6.81617428. So that is my radius. And now I just need to put that into pi times the radius squared. So basically pi times the answer squared. So if I work out what that is, that will give you an answer then of 145.96. So again, check, does it say how to round it? Nope. So I'm just going to write now 145.96. Right, the final question then for this video, oh no it's not actually, we've got 10 as well, sorry. So the penultimate question, it's working out the length and width of the rectangle. So again, this is a 6-mark question, so we don't want to leave this question completely. So in the exam you've got to think, well, what do I know about rectangles? Well, we know the top and the bottom are the same length, and then the two sides are the same length. So I can say that 5x minus y minus 8 must equal 3x plus 5y plus 4. I can do the same with the other two sides. So 3x plus y minus 4 equals 2x minus 6y minus 3. Right, so after that I'm going to try and make this look a little bit nicer. So if I put the lines down like this, what can I do? So I've got x's on both sides, so that's minus 3x. So I would get then 2x minus y minus 8, and take away the 3x there, so I just get 5y plus 4. So then what else could I do? I could add the 8 over. So I'd get 2x minus y equals 5y plus 12. And then I could add the y to get 2x equals 6y plus 12. So that's going to be a second mark for doing that. So 1 mark for that, 1 mark for that. Let's do the same with this one. So make it look a little bit nicer. So I could minus 2x from both sides. So I would get x plus y minus 4 equals minus 6y minus 3. Then I could add the 4 over. So then I would get minus 6y plus 1. And then I could add 6y. So I get x plus 7y equals 1. So then you get left with these two things. So I've got two equations, two things I don't know the value of. This is simultaneous equations. This one looks more like what you're used to. So I'm going to keep that one the same. Whereas this one, we've got x's and y's on the different sides. So if we just minus the y over, or the 6y over, to get that. And then that's going to be the second simultaneous equation. So to solve these, I'm going to times this one here by 2. So then I get 2x plus 14y equals 2. So that's going to get rid of that one now. Then the x's are the same, so I'm going to subtract the two equations. So 14y minus 6y is 20y, and 2 minus 12 is minus 10. So y is minus 10 divided by 20, which is minus a half. And then I'm going to work out what y is now, sorry, what x is now. So I know that y is minus 0.5. So if I put that back into here, then I would get 7 times minus 0.5 is minus 3.5. So it'd be x minus 3.5 equals 1. So then add the 3.5, so you get 4.5. So I know now that y equals minus 0.5, I know x equals 4.5. So if I go back to this rectangle, because we've got to work out the length and the width. So x is 4.5, y is minus 0.5, and I'm going to substitute them into here to work out the width, and then into this one to work out the length. So I would have to do 2 times x, so 2 times 4.5 is 9. Minus 6 times minus 0.5. So I mean, this is a calculator paper, so I'm trying to do this all in my head, but actually we can just type it in. So 2 times 4.5, for example, for the first bit. Then minus 6 times minus 0.5. And then minus 3. So I get that that is 9. So that is the width of the rectangle is 9. And now I'm going to substitute these in now into this one to work out the length. So I'm going to do 3 times 4.5. Then I'm going to add 5 times y, so 5 times minus 0.5. And then add 4. So that makes 15. So it'll be the length is 15 and then the width is 9. So last question then for this video. You can tell these questions are harder, which is why this video is longer. Like I said, keep watching the next one. These are, I don't know why the new exam papers, the hardest questions are always in the middle now. So this is why this video is going on for quite a long time. So again, this is a 5-mark question. So again, we don't want to leave it. So things that may seem obvious, just write them down anyway, because it might pick up a mark that you didn't think actually you would get. So, for example, the fact that 60% of the people in a town are male. So if 60% are male, that tells us that 40% are female. So that's 1 mark for doing that, even though that seems pretty easy. Right, then 20% of the males are left-handed. So if we work out 20% of 60, so 10% is 6, 20% would therefore be 12. So that is the number who are left-handed, or the percentage who are left-handed. Right, so if I take that off, the 60, that would be 48. So 48% are right-handed. So then looking at the females, we don't know any other information really, apart from the fact 21.6 of all the people are left-handed. Well, I've already got 12% of them here. So if I do 21.6 and take off the 12, that would tell me what percentage of the females are left-handed. So 21.6 take away 12 is 9.6. So that is 9.6. I don't really need to work that out, because actually what it's saying is work out the percentage of the people who are not male, so basically who are female, who are left-handed. So it's 9.6 out of 40%, so 9.6 out of 40. So I need to do 9.6 divided by 40 and then times that by 100. So that would be 24%. Right, make sure you watch the next video for the next 5 questions.